All right, in this video, we're going to look at efficiency. And again, the equation we're provided for this is that the efficiency of a process equals the energy that you get out of it divided by the energy that you put in. In other words, you always get less energy out than you put in. So this should always be a fraction less than 1. And then to make it a percent, we're going to multiply by 100. So in this situation, we are putting this much work or energy into a process, and we're getting 1,000 out. So what is the efficiency of the process? So we got 1,000 out, and we put 1,200 in. So we'll divide that and multiply by 100, and that is going to give us the efficiency of the process. And again, you should never have an efficiency over 100%. You can't put 12 cookies into the fridge and get 20 out, just into the oven rather than the fridge. So they should always be less than 100%. So this process here, in this case, would be 83.3% efficient. But let's look at some more details examples here. So here, again, I have an object that is on the floor. It's 7 kilograms. And I am pushing it with a force of 15 newtons. And I am pushing it a distance of 10 meters. So again, from earlier, the work that we are putting into this, we're exerting 15 newtons for 10 meters. So that is 150 joules. So this is the work that we are putting in, or the energy that we're putting in, you could say. And the question is, what are we getting out of that? The object's going to gain energy, but is it going to gain all of this energy? And the answer is often no. So let's figure out how much energy it gained. So it's still on the ground, so it did not gain any potential energy, but now it is moving. And before it was moving at a speed of 0, and now it's 3. So the change in kinetic energy is going to be the new kinetic energy minus the initial, which was 0. So 1/2 mv squared, 1/2 times 7 times 3 squared. So I'll just do 9 times 7 times 0.5. So I get 31.5 joules. And that is essentially the useful energy out. The rest of it is all wasted as heat. And so we don't actually consider that part of our energy out. We can figure it out. So 150 minus 31.5, the amount wasted as heat is going to be 118.5. But in terms of calculating the efficiency, efficiency is energy out over energy in. And again, energy out is just what we call the useful energy, the potential plus the kinetic. And in this case, we're only looking at the kinetic. So we're getting, the box now is 31.5, but we put 150 in. So how efficient was this process? We're going to divide 31.5 by 150 and then multiply by 100. And this is going to be then 21%. So this process is 21% efficient, which means almost 80% of the energy we put in got wasted and turned into heat as friction. And so that's the process here. Let's look at one more. So again, we have a ramp, and the ramp is 3 meters tall, but 10 meters long. And we have an object at the bottom that we are pushing with a force of 20 newtons up the ramp. And we do that for the entire length of the ramp. So the work is going to be the force we exert times the distance. So 20 times 10. So that's 200 joules that we are putting into the box. That is the energy in. And so the question is, what is our energy out? Where did that energy go? So let's start. The box gained height. So there was a change in potential energy of the box. Again, it started at 0. So the new potential energy will just be the new height, the energy from the new height, which will be 5 times 10 times 3, which will be 150 joules. If this started at a height, we would have to subtract the initial potential energy, but it didn't, so this is the change in potential energy. It says at the top of the ramp, it's moving 2. At the bottom, it said it was at rest, so the change in kinetic energy then will just equal the new value of the kinetic energy because it started at 0. So 1/2 times 5 times 2 squared. So I get 10 when I do this. 4 times 5 is 20 times 1/2. So this is it. So the rest of it is wasted as heat. We don't really care about that. We get 160 joules out that was useful. So we put in 200, we got 160 out. So the efficiency is the energy out divided by the energy in times 100. And when you go through and do that, you should get an efficiency of 80%. So better than our last thing. We're not losing as much to friction, or a smaller percentage to friction. So anyway, this is how we calculate efficiency. figure out how much you put in, figure how much you got out, and then you'll divide the two. And again, you really need to get less than 100% or you're doing something wrong. So until next time, I am Derek Genova. Have a delightful day.